Hello, welcome to Weatherwise. I'm your host, meteorologist Nathan Scott. And can you guess what today's topic will be about? I'll give you a hint. I'm wearing this shirt for a reason. Yeah, we're talking about the tropics. It is the middle of August after all, and the tropics are starting to heat up. So we'll talk everything you need to know about tropical storms, hurricanes, and also the origin behind the names of storms, why we name them in the first place, and why the names have been changing over the past several years. Let's take a look at the graphic here, though. This is all about the climatology of hurricanes in the Atlantic Ocean basin. We're looking at the number of storms per 100 years. Hurricane season in the Atlantic basin begins on June 1st and then continues all the way through November 30th. And you can clearly see where we are continuing to climb up this mountain. So the yellow, that's where you have hurricanes. And then the red is where you have hurricanes, also tropical storms over the past 100 years. You see that climb. So we're right about here. The peak of hurricane season actually happens when we get into around September 10th. And that's when we've had some really nasty, intense storms that have slammed their way into parts of the United States and also into the Caribbean. But you can have a major hurricane at any point throughout the hurricane season. It doesn't necessarily need to be right at peak. Of course, we had Hurricane Andrew that happened in Florida, 1992. And then we've had Hurricane Michael that slammed into the Florida Panhandle, and that was in October. So even though once we get past the peak, you can still never let your guard down, it does drop off significantly once we get into October, and then really drops off November, and especially into December, although you can still get tropical systems pretty much in the Caribbean Sea once it gets that late. So there you see, the season begins June 1st and then closes out November 30th, but you can still have tropical activity outside of those dates. Let's talk about some facts with hurricanes. They are intense, they are destructive, but they are needed because these intense systems transfer a lot of heat from the tropics towards the poles. If we didn't have tropical systems, the Arctic and the Antarctic would be much colder than what they are right now because you wouldn't get that conveyor belt of warm air to provide those areas of latitude with a little bit of warmth versus if there wasn't anything of a cold or conveyor belt of warm air, then that'd certainly be just a solid layer of ice throughout the entire year. These systems will never develop around the equator. You will never see tropical systems develop between the latitudes of 5 degrees north and 5 degrees south. And the reason behind that is because the rotation of the Earth creates the Coriolis force, you may have heard about this, which only impacts large weather systems. That's why high pressures go clockwise. Airflow around a high pressure is clockwise in the northern hemisphere. Airflow around a low pressure is counterclockwise in the northern hemisphere. That changes, though, in the southern hemisphere. Also, you may have heard the myth that the Coriolis force will affect which way your toilet bowl water will go. That is a myth because it's not a large enough event to be impacted by the Coriolis force. So you may have seen it on a cartoon show that the water in Australia in a toilet bowl flows differently than what it would into the northern hemisphere. Just a fun fact there. Impacts go beyond the eye of the storm. Hurricanes produce very high winds, but also devastating storm surges. We saw that with Hurricane Katrina. Even though the eye made its way into Mississippi for the most part, of course, all the news was really directed in a large part of what happened in New Orleans with the flooding. And then also with the flooding rains, you can have inland flooding. Inches, 10, 20 inches of flooding that can happen hundreds of miles inland after the system has made landfall. That happened in New England, in Vermont, in New Hampshire. They had catastrophic flooding when I believe Hurricane Irene hit those folks several years ago. And then, of course, you also have tornadoes. Just because once that spin reaches land, the friction of the land causes a little more ability for these storms to produce tornadoes. And some storms produce more tornadoes than others. You can have a strong hurricane, makes landfall, may not produce as many tornadoes as a weak tropical storm could produce more tornadoes. And there's just a lot of factors that determine on that tornado potential. What do we need for a tropical system or a hurricane to develop in the first place? Well, this is basically a living and breathing machine. And the first ingredient that you need is the water temperature has to be 80 degrees or above for the most part. You need that warm water for these storms to initiate. So you have that warm water in place. You need to have some convergence where the winds come together and force air upwards. Once you have this start to develop, you have showers and thunderstorms that start to build, and there'll be a cluster of showers and storms. You have to have a lot of moisture in place. That's why they form in the tropics, because there's so much moisture in the tropics around the globe. And then also you have to have no dry air. When you have dust from the Sahara, that can impede the formation of tropical systems, and also especially with hurricanes. So that is good news when you have Saharan dust. We talked about that in earlier weather-wise. Saharan dust cuts down on that chance of strengthening with tropical systems, but even the potential of a tropical storm developing. Another thing you got to have is winds have to be calm around the surface, or light around the surface low that's trying to develop. If you have too much in the form of wind shear, that will tear the system apart, and it won't come together, and it won't form that center low that can have the storms really rotate. So you need those four things for storms to really blow up and then start to spin like a top, and then those storms continue to spin up. They produce latent heat, and they eventually start to continue to develop a low pressure system at the surface. Meanwhile, it's a high pressure system aloft, and you see the winds going out of the storm, and that storm kind of pretty much breathes, so it needs that room to breathe. If you don't have the evacuation of air with this system, it can't grow into a monster major hurricane. Hurricane rating. So when you have a system that develops a tropical wave, we have some of those that happen throughout the course of the year. Of course, they usually come from the western areas of Africa and then march their way across the Atlantic. A tropical wave is basically a system that's producing a lot of rain. It's a cluster of storms, but doesn't really have any real rotation with it yet. Then once the tropical wave starts to get a little bit of a low pressure and starts to develop more low rotation and starts to have sustained winds of 35 miles per hour, that is when a tropical depression forms. Once it's 39 miles per hour or greater, then you have a tropical storm. And then once it gets to 74 miles per hour or greater with sustained winds, you have a hurricane. And hurricanes are broken down with a Saffir-Simpson scale. And this is just a nice demonstration on the power of a hurricane. Say this example is right along the coast, and why we always tell people to evacuate the coastline. So there's a breakdown. Category 1, winds 74 to 95 miles per hour. A lot of people just write off a Category 1. Oh, it's a Category 1. I don't have to worry about it. Winds of 74 to 95 miles per hour is still very, very powerful winds and can still create a lot of damage. I mean, you look at that here in Arkansas, and you get a severe storm that produces 75 to 80 mile per hour winds, you're going to have trees down. You're going to have power lines down. The good news is with a hurricane, you usually have some sort of notification several days in advance that you can prepare and put up those boards around your windows and block out some of the wind. Nonetheless, it can also still produce a storm surge of 3 to 4 feet. Then you jump to a Category 2, which is a moderate damage is expected, 96 to 110 mile per hour winds, 5 to 8 foot storm surge, and that's not including the waves on top of that storm surge. So as the hurricane starts to approach land, all that rising air is also building up the ocean and the water with it as well. So you have this blob of water that's coming into land, and that's what's known as a storm surge. So in this case, it's 5 to 8 feet. But with the winds, 96 to 110 miles per hour, you may have waves that are 5 to 10 feet. So you got to think about that when you look at the storm surge. It's just not that 5 to 8 foot number that you have to pay attention to. You also have to think about the waves on top of the storm surge that's also producing a lot of destruction. Once we reach Category 3, that is, of course, a major hurricane packing winds of 111 to 130 miles per hour. The storm surge, 9 to 12 feet, but that can vary also dependent upon the shoreline and how far the continental shelf goes out, and also if there's like an enclosed shoreline that will allow for more water to build its way in. When Hurricane Katrina hit, some storm surge in Bay St. Louis area and parts of Louisiana was 15 feet, but other locations saw 25-foot storm surges, which created all that catastrophic damage that we're all familiar with. Category 4, extreme 131 mile per hour winds to 155, a 13 to 18 storm surge. And then, of course, the Category 5, which fortunately doesn't happen very often, but when they do make landfall, it's devastating, not only because of the winds, but also that storm surge of 18 feet. And you can see the house is gone and everything else is pretty much gone. And usually it's just nothing left, especially on the shorelines and the barrier islands and the coastal areas when you have a Category 5 that does make landfall. Next, we're going to continue to talk about the tropical development and what tropical systems really need to get going in the first place. Stay tuned. We talked about how tropical systems form in the first place. You need a warm water, 80 degrees or higher than that. Also, you got to have a lot of moisture in place, and along with that, you have to have low wind shear. Not too much winds, otherwise the system gets torn apart. But one of the key ingredients is to have some sort of convergence to produce lifting air in the first place. And there's 3 different ways to get this motion to happen. The most common one is the tropical waves. You see them make their way from the west coast of Africa, drift across the Atlantic. Some will become tropical systems, others won't. And that just depends on, is there dry air in place? Is there wind shear in place? All those factors working against tropical system formation. Another way is actually to have a fast-moving line of storms that come off the coast of Africa, which usually move faster than a tropical wave, but at times it can start to get rotation, and then the process of a tropical system begins. What you may have never heard before is a tropical upper tropospheric trough, or a TUT. And this is a trough or a cold core low in the upper parts of the atmosphere, a pocket of cold air basically, that can develop into something warm core, because your tropical systems are warm core systems. Your systems that we typically deal with in the mid-latitudes, those are cold core systems. Another way is the old frontal boundary. We see this happen a lot. Cold front makes its way through, drops its way to the deep south, and then stalls out over the Gulf or the Atlantic Ocean. And when you have these fronts that stall out and linger for several days, those have to be watched because they can produce some lift over warm waters off the coast of North Carolina, Georgia, Florida, off the Gulf Coast, because you have winds coming from the north and winds coming from the south, and that does produce convergence along a frontal boundary, and that can lead to also tropical system development. So where do storms develop? Not only in the Atlantic, but across the globe. And they're called different things depending on where these systems develop across the world. So there is the Atlantic Basin. Like I said, you have them develop off the west coast of Africa, and then the arrows show where they go. So they go from the west coast of Africa, they may stay out in the Atlantic, they may hook their way towards the United States, they may take more of a southern route, go through the Leeward Islands or the Windward Islands, and then into the Caribbean Sea and eventually in the Gulf. But also you have storms that develop right along Central America, and that can also make their way into the Gulf. So there's several areas that we're always watching throughout hurricane season, and goes from a tropical storm to a hurricane. Then you've noticed a lot of times we're also watching what happens in the Eastern Pacific, and that's because you have tropical storms, which are also still hurricanes once they reach that threshold of 74-mile-per-hour winds or greater. The good news is here, typically your systems, they'll develop off the coast of Mexico, and then a lot of times they'll just stay out in the Pacific and die out. Sometimes they do hook their way into Mexico or the Baja of California, but you do not have a hurricane that will hit California. The chance of that is so rare, and the reason behind that is because you have to think about the ocean current. It's coming from Alaska. If you've been out to California, you know how cold that water is. A tropical system makes its way up in that latitude, moving north, it falls apart. It can't survive because it loses that fuel. The warm water is the fuel for these systems to survive, and once you take that warm water away, they really fall apart. Sometimes hurricanes do impact Hawaii. A lot of times the islands do miss them, but you probably remember Iniki back in the day that really devastated the Hawaiian Islands. Once a storm crosses the international date line, it goes from being a hurricane to a typhoon, and this part of the world is the most active part for tropical cyclones. That's just because you have so much warm water in this part of the globe, and then also the expanse of that warm water. Typhoons are going to be much more powerful and usually bigger than the hurricanes that we have in the Atlantic, and instead of a major hurricane, it will go to a super typhoon once it reaches that relatable Category 3 status. Impacts Japan, the Philippines, Guam, and other islands, but also it can make its way into China or Vietnam or Thailand, also gets tropical systems. When you get into the Indian Ocean, the Bay of Bengal, towards India, Sri Lanka, they call them cyclones. So it goes from a tropical storm to a cyclone, or a cyclonic storm is also another term they use. And those produce huge amounts of rain, devastating floods for India, Myanmar, also into parts of Pakistan as well. Then down into the southern hemisphere, we have cyclones once again that will make their way from the eastern part of the Indian Ocean over to the western part, and that affects places like Madagascar and other countries in Africa. And we also have cyclones that develop around Australia, New Caledonia, and the Solomon Islands that can impact parts of Australia. So a lot of parts of the globe do see tropical systems, but the highest amount of tropical systems happen into the Western Pacific. Let's go back to the Atlantic Basin though, because now we're going to look at the frequency. I showed you a hurricane season graphic, but take a look at the frequency of the number of named storms per 100 years when we break it down month by month. So we got 10 to 29 for the month of June, and we do have systems that develop in June. They can develop in the Gulf, they can develop off the Atlantic, usually when you have stalled out fronts, happens a lot of times. But look what happens once we get into July. Then we get to a little category of 30 to 49 just off the Carolina coast and also the mid-Atlantic. August, then you start to see those tropical waves become a player as the reds start to show up just to the east of the Windward Islands in the Caribbean. And then also a bullseye happening just off the east coast. September, look at all the red. So that just tells you, and this is all dictated by a high pressure that is always out in the Atlantic Ocean. So there's a Bermuda high. And where that high is is a factor in where these storms go. If the high is more to the east, it can pick up those storms and keep them out the Atlantic or steer them towards Bermuda. If that high is more to the west, it can keep those storms on more of a southern track, make their way through the Caribbean, the Bahamas, and then eventually the East Coast or the Gulf. And here you go. Once we get into October, it really starts to tick back dramatically, but we've had some nasty storms in October as well, and look what happens in November. It really starts to fade away and primarily starts to aim more towards Central America, but there can still also be some tropical systems even into Florida. So here's the average dates, 1991 to 2020, on when we usually have a tropical system develop and how many develop. So looking at number 4, because we've been through Dexter, now we're at Aaron, so we're at number 5. And when you look at that, we're looking at August 22nd is usually when we have our 5th named storm. And a hurricane, that doesn't happen until September 28th. So our first hurricane, which most likely will be Aaron, looks like it's right on target. August 11th, usually you have a second one around August 26th. And then a first major hurricane typically happens around September 1st. So I mentioned we do have Aaron out there right now. This was recorded August 11th, by the way. So what is in a name? Why is it named Aaron in the first place? And could your name ever show up when we have a tropical system named? I'll have that before we close out weather-wise coming up. Now that we are in Atlantic hurricane season, we've already heard some of the names showing up here on the board. We've already been through Andrea, Barry, Chantal, Dexter, and now we have Aaron on the board. But you see, those names continue to go all the way down the list until W. Hopefully we don't reach W, but the several years we've had made its way even past that list, especially in 2005. We made our way into the Greek letters. Let's talk about names though, because here are all the names for the next 6 years. 2025, 2026, 2027, 2028, all the way to 2030. And we know this list because the World Meteorological Organization comes up with this list, and this list changes as needed on what happened with the hurricane season before. What you also notice is in the Atlantic Basin, we do not use the letters Q, U, X, Y, or Z. That's different across the world, though. The Eastern Pacific does use Z and Y, and they may use X. So when we talk about the history of naming storms, this has been going on for many, many years. But here's the breakdown. Hundreds of years, many hurricanes were named in the West Indies. They were named after saints when the hurricane occurred, and they were also named after holidays, if it was close to a holiday. I'm sure you've probably heard of the Labor Day hurricane that made its way across the Florida Keys. So Puerto Rico, 1876 and 1928, those systems were named after a saint. Then we start to use random female names until 1953. The USA used a phonetic alphabet, which is A, B, C, D, E, and so on, but it was only female names. We did not start using male names until 1978 in the Eastern North Pacific, and in 1979, that's when the names began to change to both genders in the Atlantic and Gulf basins. The names are rotated every 6 years in the Atlantic, and it only changes if a destructive storm made its way through. That name will be removed and replaced by the World Meteorological Organization, which is based out of Geneva, Switzerland. You also have probably noticed that Some names are more multicultural because these names are supposed to include the areas that they impact. So we don't just go with English names, of course, in the list anymore. We integrate more of French names, Spanish names, and sometimes it's a little more challenging for meteorologists to say these names. We have a pronunciation key, which is nice. But I know there was a name for ice storm, Isaias, which it looked like Isaias, but it was not pronounced that way. And that's just because you have storms that impact Puerto Rico. You have storms that impact Central America. So they want to make everything equal in terms of using all names and all genders across the board. I talked about retired names. Here's the list of all the names that will never be used again. That's 99 names. You may be familiar with, of course, Camille, but then you have Agnes. Agnes was terrible in the Mid-Atlantic and Northeast. My parents talked about that. Just produced so much rainfall in that part of the country. Hazel was also a bad one back in the 1950s. The 1980s, Hugo, of course, just destroyed Charleston, South Carolina. 1990s, Andrew, Floyd. I remember Floyd when I was a kid. 1999, it impacted the Mid-Atlantic, produced like 20 inches of rain at my home and just saw flooding I've never seen before. Then you get into the 2000s and you have names like Charlie that impacted the west coast of Florida, very close to the Tampa area. Felix, Ike, Iris, Isabel, Isidore, Ivan, Rita, Stan, Wilma. Wilma was all the 2005 devastating hurricane. I mean, 2005 was a bad year across the southeast and the Atlantic coast. And then 2010, 2024, the newest names to be retired are from last year: Beryl, Helene, and also Milton. So this is just a fun fact because you're thinking, okay, so what letter that starts with a storm name is most commonly retired? So I went through the list and I broke down every letter, and you see F is a big one, but most retired names are from the letter I storms. 14 since 1954. However, you also have to remember, when you look at this graphic, okay, what gender was it? Was it female? Was it male? And also include the Greek letters. 60 out of the 99 were female, 39 were male, but before 1979, only females were used, so that included 26 names. So if you take 26, subtract it from 60, then you get more of a closer number with that ratio. So that is the conclusion of this episode of Weatherwise, and I think this is just going to be like part one to a two-part series about tropical weather, because we haven't even discussed all about how to forecast and look at weather information, all the information that we look at as a meteorologist to figure out where storms are going to go, the intensity forecast. There's a lot more to discuss. So thanks for watching. And if you have a topic that you want me to discuss here on Weatherwise, please send me an email, nscott@thv11.com, or reach out to me on Facebook. Until next time, have a great day, and I'll see you soon.